exponents that can be written as a fraction. So you've kind of dealt with these before. When you had an exponent of 2, is 2 a rational number? Is 2 a rational number? Yes. Okay, it can be written as a fraction, 2 over 1. Okay. But have you ever seen something with an exponent of like 3 over 2? Where 3 over 2 is the power that's being placed on the... No. Okay, so actually you have. You've just seen it written a different way. So everything we're going to do and calculate, you guys have been calculating while you were doing radicals. It's just that you wrote them as radicals, and what you didn't know is that instead of using the radical symbol with the little index written inside, the little radical part, you could actually have written that as an exponent instead. Okay? And so what that means is this. Say I had some number to the power of 1 over n. So that's the thing you've never seen before, right? What does that mean? That is really the same thing as saying that a is inside of a radical and that the index of the radical is n. Okay? So basically, the new part of the exponent that you've never seen before is having an exponent where there's actually something in the denominator. That denominator really means that you have a radical with that index. Okay? So if something has this power, m over n, you've seen a to the m before. That means a raised to the power of m, whatever number m is. But when I put it over n, what that means is a is still raised to the power of m. That part doesn't change. So if this was a squared, this is a squared. Okay? The difference is when you add a denominator, you've now added a radical with an index of that number there. Okay? And because in exponent rules, let's say you had a number and you wanted to square it and you also wanted to cube it, would it matter which order that you did those in? You could square it, then cube it, or cube it, then square it, right? So this idea, also the order doesn't matter. If you want to raise this to the power of m and then take the radical, fine. But if it's easier to take the radical to make the number smaller first and then raise it to that power, those are the same thing. Okay? So is this okay with everybody, the fact that when you see an exponent that's written as a fraction, you're really seeing a radical just in a different way than you're used to seeing it? Okay? So if your brain has to process it, you could rewrite it in radical form. Why would we do this? We'll show you some things that we couldn't simplify before, but if we understand how to write it as a fraction, we could actually simplify a little further than we would have been able to before. Does that make sense to everybody? Okay. Any questions on the notation? So a fraction exponent really means you're trying to simplify something like you would with a radical. Okay. All right, don't write all this down. If you have the note-taking guide, it's in there. If you don't have the note-taking guide, this is strictly copied straight out of your book. Basically, these are all the exponent rules that you knew from the past. Okay? If you have a base, the base has different exponents, and you're multiplying the two powers together, you add the exponents. Here, you multiply the exponents. Here, the exponent can be applied to each one, and then it just has examples of that. The point is, the exponent rules that you know, those still completely apply even if the exponent is 1/2 instead of 2. Okay, so just because we're allowed to use a fraction as an exponent now and we're adding this piece of knowledge that we know what that means, it doesn't change any of the exponent rules. Is that okay with everybody? So these are all the rules that you already know. Don't forget that if you have a negative exponent, that's like having 1 over that power with a positive exponent. Okay? All right, so again, don't copy those all down. They're literally straight from a page in your book. All right, so when somebody says, what's 625 to the 1/4 power, can somebody rephrase to me in a different way what they're actually asking us to find? Zeke? Good. That's the same thing as saying, what is the 4th root of 625? So if your brain has to think about it this way, then think about it this way. Okay. So what is the 4th root of 625? 5. Okay. And if you weren't sure, you would start breaking it down to a factor tree and you would find groups of 4 roots. Those are the lessons that we did last week, right? So we're not going to spend as much time today about how did you get that the 4th root of 625 is 5. That's what we worked on last week. today's message is, how do I know that 625 to the 1/4 power means the 4th root of 625? Okay, letting that knowledge transfer into our head. Okay, what about part B? 12 to the 1/2 power times 12 to the 1/2 power. Any ideas about what this is going to work out to be? Damien?
2/2, which is 1.
Good, and what's the base? Okay, so let me ask you guys something. If I had x to the 3rd times x to the 2nd, what would that simplify to be? X to the 5th. This part stayed x, and then these added together to make 5. So if I have 12 to the 1/2 times 12 to the 1/2, he's correct that we can add the exponents because the base is the same, and 1/2 plus 1/2 is 2/2, or 1. So the exponent is 1, but what base is that on? 12. Because we don't change it, we're just saying, oh, you have 12 to a power, I have 12 to another power. We can rewrite that as 12 to one bigger power instead of actually working it out and then multiplying it. So 12 to the 1st power is just 12. Okay? So again, the exponents work the same way the exponents have always worked. All right, so what about part C? We have 12 to the 1/3 times 18 to the 1/3. Any ideas on how we're going to simplify this? It's different than part B because they don't both have a base of 12. So are we out of luck, or is there something we can do? Damien?
Can we put it 12 to the 3rd power? 12 to the 3rd root. 12 is under the radical. And the 18, same thing.
Okay, so he says, think about it a different way, and then let me ask you guys the same thing I asked before. Can you simplify this? Can you combine this together and make it one factor instead of two? So this would be a problem you would have saw in last week's lessons, right? And you could work on cube root of 12 times cube root of 18. How big the number ends up underneath the radical, and if it simplifies, we would have to see. But if we can do this, that means we can do that. So just to emphasize to you why the exponent rule works, so I'm just rewriting it another way right now. Even though they didn't have the same base, they had the same exponent, which really means that you were looking at this, 12 times 18 all being raised to the 1/3 power. Because remember, your exponent rules from the past say if you have two factors that are both being raised to a power, that power can be distributed to each of the factors. Okay? So either the base is the same and we can combine them together, or the exponent's the same so we can combine the bases together. Okay? So you can think of the problem like this or like this. Okay? So we can either multiply 18 and 12 together, or what might we want to do if we didn't have a calculator and we don't want to spend the time multiplying 12 and 18 right now? Factors. Good. So I'm going to go ahead and factor both of them just to see, is there going to be a cube root of anything that I'm going to be able to work with? Okay, so there's all the factors of 18 times 12. Okay, do we have some perfect cubes in here? Things with groups of 3 factors. So we have a group of 3 2s. Again, individually 12 and 18 didn't have factors, but once they're multiplying together all underneath the same radical, we can combine all their factors together. And then there's another group of 3 factors of 3, and then there's no leftover factors, which means a 3 will come out from under the radical, so will a factor of 2, giving us a result of 6. Okay? Or you could have multiplied the 12 and 18 together and then broke it down, but I was just trying to give you guys tips without calculators last time about how we can do that. Okay? Is this all right with everybody? So interpreting in our brain, trying to, 2 things. 1, what does that fraction exponent mean? And then 2, parts B and part C were nothing new. Okay? The second part of them was new, like what does the fraction mean? Oh, it means 3rd root, so I'm going to look for these groups of 3. But how the exponent rules work didn't change there. Okay, so that's kind of like review of those exponent rules. All right, so a little what if kind of thing. So let me give you this problem. Let me think of a good one. Let me do let's say you had 9 to the 1/4 or the 4th root of 9. Okay, those are the same thing. Is everybody okay with the fact that I just wrote two of the same thing up on the board? So the or between them is just saying you could write it either way. Is that completely simplified? Okay, it kind of depends on what the definition of simplified is. So if the definition of simplified is there any factors of 4 in the number 9? Are there? Any groups of 4 of the same factor? No. So in that sense, it is simplified. But with radicals with a different index, there's actually a little bit more to simplifying than what we would have thought of before. Besides just making sure that you're not taking any more factors out of the radicand, you also have to try to make the index as small as possible. And what I mean by that is maybe the 4th root of 9 is the same thing as the cube root or the square root of something else. Then that would be a better way to write it because it would have a smaller index than 4. Okay, so if 9, basically because 4, how many indexes are there below that? There's 3, that's one option, or there's 2, that's another option. 1 is not an option. Remember, roots don't start till you're trying to find groups of factors. So only if I can rewrite the 4th root of 9 as a square root or a cube root is there any way to simplify this. Okay? So the reason that we don't talk about this until we get to the exponent part is to use some of our exponent rules to help us. So I'm actually going to use the way that it's written in this form. Okay? So if I think about 9 to the 1/4 power, basically if I want to lower the index, the question is there a way to rewrite 9 as a power of something, and specifically where this power, when these two exponents combine together and multiply, would reduce 1/4 down to 1/3 or 1/2. Okay? Can 1/4 be reduced down to 1/3? No. So that option's gone. Okay? Which means either the 4th root of 9 is the most simplified version, or the 4th root of 9 is the same thing as the square root of something else. Okay? The 4th root of 9 won't be the same thing as the square root of 9. Okay? But maybe that. Is there a way for us to rewrite 9 as a power of another number? 3 squared. Okay? Is something to the second power worth exploring? Is that going to reduce this 1/4 when these two things are multiplied together? So does 2 times 1/4 reduce to something else? Yes. So it's worth looking at this as 3 squared. Okay? Yes.
What if you have like an exponent like 9 over 1/4, but it was, and it said 9 over 8 over 16? Do you reduce that or keep it the same?
Reduce it. Okay? Yep. All right, so now I have a base of 3. And what am I going to get when this exponent of 2 multiplies the exponent of 1/4? What's 2 times 1/4? 1/2. Okay? So this is telling me 9 to the 1/4 power is the same thing as 3 to the 1/2 power, which means if I get this as a final answer, it's actually considered simpler to write it as 3 to the 1/2. Or if I get the 4th root of 9 as an answer, it's actually simpler to write it as the square root of 3. Okay? All right, so when should you even look at this? Because I get it. This is kind of like difficult. So let's say you have an answer to a problem. You think the problem's done, and then you say, oh, I remember Mrs. Dahl telling me like it's not finished simplified until I do all this stuff. What would you glance at to kind of ask yourself, can I simplify this any further? Okay, so you would look closely at the index, okay, right, as well as the number under here. If this was 10, if this had been the 4th root of 10, sorry, that was really ugly, yeah. Okay, if this had been the 4th root of 10, would I have even gone through the rest of this process? No, because 10 is not a number that's special as far as being written as a power of another number, right? So I'm not even going to care about this unless the number is something like 9, where it could be written as a perfect square or a perfect cube of something else. Then I would want to worry about it. Okay? So like if 27 was underneath a radical, and I haven't put the index in yet, 27 would be worth looking at because it's 3 to the third power, right? But only if the index was something like what? Somebody give me an index that if I put it here, that root of 27 could actually be rewritten as a different radical. CJ? Just like? Good. So the sixth root of 27, because this is like 27 to the 1/6 power, but if 27 is rewritten as its perfect cube, the 1/6 and the power of 3 would reduce to be 1/2. So the sixth root of 27 is really the same thing as the square root of 3. Does that make sense to everybody? So I'm not going to do this every time. I'm only going to do it if the number, the radicand, the number underneath the radical is a perfect square, perfect cube, perfect something like that. And then once I find that, I'm going to think about it, and I'm only going to pursue it if it's something that could actually reduce the index right here. Okay? So we'll see that more as we do one of the problems. All right, so the next thing we want to do is just rewrite things from exponent form to radical form. Okay? So in part 1 of the example, -2y to the 4/5. The 4/5 exponent is on what? What factor is to the power of 4/5? Y. Is 2 also to the power of 4/5? No. Okay? So -2 is not in a radical. It doesn't have a rational exponent on it. Okay? Y is in a radical. What's the index of the radical that y would be underneath? 5, because the denominator of the exponent. And then y would be raised to the power of 4. Okay? And that can't be simplified, so this is fine. So this is how it's written in radical form from exponent form. Okay? All right, what about part 2? D to the -3/2. Who thinks they have an idea of how that should be written? Anna? Good. Okay, so why 1/? Why is that part in there, Jack? Good. So the -3/2. So if you need a step before that, she took care of the negative, right? Then she rewrote whatever had the fraction exponent in radical form. And then the question is, can we simplify this further? Okay? Can we rewrite the square root of d to the 3rd? We can. How many factors of d are underneath this radical? 3. We can take some out. It's a square root with an index of 2. So how many groups of 2 are there? 1. So 1d would come outside, and then there'd be one that wasn't in the group of 2. Okay. And then should we leave the radical in the denominator? No. So we're just, in rewriting, we have to use a lot of the skills about how radicals should be worked with, right? What should I multiply numerator and denominator by so that there isn't a radical in the denominator? Rad d. So we make a pair since our index is 2. Okay, and then our denominator will be d squared, because here's one factor of d, and then together these will make another factor of d, and d times d will give me d squared. Okay. Is this all right? Okay. You could have actually done this whole thing in exponent form without even going into radicals. So those of you that like your exponent rules and are comfortable with it, once you got to this step right here, I know the directions said radical form, so that's right for this one, but I'm just pointing out to you that you can do this. If it just says simplify and it doesn't say radical or exponent form, you could simplify in exponent form, but you have to recognize that having this fraction power in the denominator is the same thing as having a radical in the denominator. So is it okay for me to leave d to the 3/2 power in the denominator? No, okay? If I wanted this to be a whole number, what power of d do I want to multiply by? So what exponent do I want added with 3/2 so that it makes d to some power that will reduce to a whole number instead of a fractional amount? So it's going to have a 2 in the denominator, so they have a common denominator and can be added together. Okay? And 3 plus what so that I get something that's divisible by 2? 1. And then that would make 4 over 2. And then in the numerator, d to the 1/2. And so in fraction form, again, note for future, this is what my answer looks like. Does that match what I have in radical form? Yeah. So if you aren't as comfortable with the exponent portion of it, you could actually change it to radicals and do this. And then even if they said write the answer with rational exponents instead of with radicals, you could then just rewrite this with the exponents if you wanted. Okay, so just so that you see the connection there, that you now have multiple ways to work out the problem, in exponent form or in radical form. Okay, sometimes you can't get further unless you try the other form, but other times you can work out however you're most comfortable to get to your answer. Okay? All right, so go ahead and take a minute and write these in exponent form. Should be on B. 3/2. Good. This is a to the 1/2, b to the 3/2. Okay. And then what should be the power on W in part 2? 2/3. Is this all right? So mostly a notation thing. Yes? No, because the A doesn't have the third power on it. Does that make sense why? So right now, A only has an exponent of 1. If A and B had both been in parentheses, then they could both be in parentheses here as if they both have the third power on them. Okay? All right. What's the simplest form of the expression? So, part A. If we had been talking about this last week, could we multiply the 6th root of 10 times the cube root of 10? No, right? Different indexes, we wouldn't know how to do that. But now that we know how to write it a different way, we have to check the other avenue, right? So at first glance, I think, I don't know if this can be simplified because radical rules, there's no rule for me to be able to get through this operation, okay? But then I know that radicals are really exponents in disguise, so I'm going to rewrite this problem in exponent form, and then I'm going to ask myself again, can it be simplified? So there's the problem rewritten with exponents instead of with radicals. Can you simplify this expression? Do both powers have the same base? Yes, they both have a base of 10, okay? So if this was x to the 1/6 power times x to the 1/3 power, can you combine them together and write it as x to a single power? You can, using your regular exponent rules. So don't be confused by the fractions. You still have to follow the regular exponent rules. If these both have a base of 10, that means I can write this as 10 to some new power, and that new power will be found by doing what? Adding the exponents, because they're following the same rule that we did before. So basically, the new exponent on 10 will be whatever 1/6 plus 1/3 is. Okay? And so I would find a common denominator for these to add my fractions together. So I would get 10 to the 3/6, which is the same thing as 10 to the 1/2. Okay? So I want to call this my answer. It's a square root. I can't write it with any index smaller, so I don't have to worry about that special kind of simplifying that we talked about a little bit earlier. This would be good. Okay? All right, what about part B? The 4th root of 64. Yeah? Yeah. Mm-hmm. Like radical or exponential. If it doesn't specify, you can leave it in both. I will say that I think the way that the book does it is it will say like simplify, and if it was given to you in radical form, they would probably have radical form, and the answer is given to you in exponent form, they'd probably have exponent form. What I'll do on your test is I will write, if I want a specific form of the answer, leave your answer in radical form. However, if the questions are like we saw on a previous slide, write in radical form. I don't need to say then, leave your answer in radical form. It says write it in radical form. But if it's just a simplifying question and I have a preference, I will state it in the directions. And if I don't have a preference, either answer will do as long as they are equivalent. Okay? All right, what about part B? So does 64 have a 4th root? No? Okay. Can anything be taken out of the 4th root of 64? Can it simplify at all? Yes? Okay, so 64 breaks down to be what? 8 and 8. Each 8 is like 3 2s, right? So eventually when you get to the end of your tree, you have 6 2s. Okay? So there's one group of 4. So 2 will go outside. And then left inside is 2 times 2, which is 4. Okay? So that part of it's done. We could have done that last week. Is 2 times the 4th root of 4 the most simplified way to write this answer? Okay, so everything's been taken out that can be taken out, but then we have to think about, is this as small as it could possibly be, right? So first, are there radicals that exist with a smaller index than 4? Yeah, cube roots and square roots, right? Then second, is the radicand something that can be rewritten as a power of something else? Yes. Okay, then we should go off to the side and kind of explore what we have. So right now we have 4 to the 1/4. There is smaller indexes. This can be rewritten, so I'm going to experiment over here and see if I can write it in a way that reduces this fraction exponent. Okay, so what's a way I could rewrite 4? 2 squared. And when that 2 multiplies with the 1/4, I will be able to reduce the denominator. Yes. Okay, so this will be really 2 to the 1/2 power. So the final answer here that you would end up seeing won't say 2 times the 4th root of 4. Instead, it'll say 2. That stayed the same from the beginning. And then the 4th root of 4 is rewritten as the square root of 2. Again, to decide to venture down that path, first there has to be an option for a smaller index. Second, the radicand has to be a number that could be rewritten as a perfect square, perfect cube, something like that. Then try it. Only if these reduce like this did here do you need to rewrite it in that new form. Okay? So we would have 2 rod 2. Okay? All right. All right, so what is each number in simplest form? Negative 64 to the 5/3 power. What does that mean? Somebody translate for me how you're thinking about it in your head if you're going to try and figure that out. Elijah? Good. Okay, so it's a cube root of negative 64 to the 5th power. Now, you guys have choices. You can raise 64 to the 5th power first, or you can take the cube root. Here's the order in which I do them. I would rather make things smaller than larger. So I would prefer to see if it has a cube root first. If it does, I'll do that first, and then I'll think about the power, rather than making it humongous and then trying to break down the radical. So does negative 64 have a cube root? Yes. The cube root of negative 64 is negative 4, right? And then I could raise that to the 5th power. Okay? So I don't know what that will be. Let's see. 256 times 4. Somebody with a calculator can verify for me. Negative 1,024. Okay, thank you, Gideon. All right, now part B, the exponent says negative 1.2. How would I want to rewrite that if I want to understand this better? See? Okay, good. So negative 1.2 means negative 1 2/10, or negative 1 1/5, which if I want to write that as a single fraction, 5 times 1 is 5, plus 1 is 6. Oops. Yeah, don't really know why I did that. Okay, so I would get negative 6/5 as my exponent. Okay, so if you get a decimal exponent, try rewriting it as a fraction, since that's how we think about the rational exponent. Technically, that decimal ends, so it's a rational number, but it's a little more understandable if we see it in fraction form. So now that I know negative 1.2 is the same as negative 6/5, what are they asking me to do in this problem? So how am I going to go about calculating this? So if someone called you up tonight, I know you guys don't call each other a lot, okay? Someone texted you a picture of this problem and said, I don't get how to do this, okay? What would you explain to them that they're doing? See these hands? I want a new person that hasn't talked to me yet, so I make sure that you understand what this means. So they say, I'm supposed to figure out what 32 to the negative 6/5 power is. What am I supposed to be doing? Quentin? for I can't listen to one number and write another number at the same time. Okay, so it's 1 over, because of the negative part of the exponent. And then, because of the fraction part of the exponent, it's the 5th root of 32 to the 6th power. Okay? Again, if 32 has a 5th root, I'm going to do that before I raise it to the 6th power, because it's easier to make the number really small and then raise it to a power than it is to take like a huge number and try to break it down. So what is the 5th root of 32? 2. So this is the same thing as having 1 over 2 to the 6th. Okay, and 2 to the 6th is 64. Okay, so this is 1 over 64. Is that all right? Again, a big notation is what you have to wrap your mind around the most, right? The simplifying the radicals isn't any different than before. It's just that you're not used to seeing these fraction exponents. All right, so the last question, what is each one up here in its simplest form? Okay. So remember your exponent rules. If you have a bunch of factors in a set of parentheses and you have an exponent outside the parentheses, each of those factors is affected by that exponent. So that 3 over 2 is going to be an exponent on 9, on y, and on x. Okay? So 9 to the 3/2 power means the square root of 9. Do you know the square root of 9? 3, right? And then cubing it, so 3 cubed would be 27. Y to the 3 over 2 is just y to the 3 over 2. There's nothing much we can do about that. And then the square root of x to the 3/2 power. So this is like x to the 1/2 being raised to the 3/2, which ends up looking like x to the 3/4 power. Okay? This is what it looks like in exponent form. Okay? How would this look in radical form? Now, to write something in radical form, you have to put them underneath the same radical. Right now, can y and x go underneath a radical with the same index? No. Okay? So if we wanted to write this in radical form, we could have a 27 outside the radical because it doesn't have any exponent on it. But for these two to get into the same radical, we have to be able to put one index here. What is the common denominator we could create if we have halves and fourths right now? 4. Okay? This one can't become a 2 because we can't reduce this any lower because they don't have a common factor, right? But we can rewrite 3 over 2 as something with 4 if we wanted. So we could make them both into something with a 4th root. So if they let us write our exponent answer, that's our answer. Okay? If they make us write it in radical form, here's how it would look. Underneath this 4th root would be x to the 3rd. I know that automatically because it already had its exponent written with the index of 4. Right now, y is to the 3/2 power. What does that get turned into if you're trying to write the power with a denominator of 4? Z? Okay, so y to the 6th. And then this could be simplified a little bit, right? Besides the 27 outside the radical, y has 6 factors underneath a 4th root. How many powers of y can be written outside the radical? 1, because there's one group of 4. Okay? And then how many will be left inside the radical? Y squared and x cubed. Okay? Now, y squared, the 4th root of that, that's not as simple as it can be written. But because we want the y and the x underneath the same radical, that's as good as we can do right now. If this was by itself, we wouldn't have gone to write it in the 4th root, right? But with other stuff that can't be simplified, this is as good as we can do. So this would be the most simplified version in radical form, okay? So really this unit is all about kind of manipulating and rewriting with this new tool of being able to rewrite radicals as exponents. But I think part of the hard part for you guys is going to be the idea that rewriting them in exponent form means that all those exponent rules you learned in Algebra 1 still exist for all these different radical expressions. So you have to remember them and get good at using them. Does that make sense to everybody? Okay. All right, so tonight's homework is homework 4. We're okay with it.